Hello, welcome everyone to this session entitled Android Studio for Experts. Congratulations on passing the expert exam at the door. The format for this is going to be all demos. You probably know some of these tricks and tips, but hopefully not all of them. And we're going to take turns. These are members from the studio team. We're going to take turns doing our own individual demos. So I guess I'll just get started.
Thank you.
So I'm going to show you some editor tricks. Can we go to, yes, you're already showing the IDE. So the first thing I want to show you is code completion. Small little trick when you're doing completion like this. If you just press enter to choose, it's going to basically insert and break your code like this. And what you probably want to know is that you should press tab instead. That'll replace the symbol under the caret. All right. All right. Some of you already learned something. That's great. All right. The other code completion trick is code completion is really, really smart. And so generally, all you have to do is just press Control Space. But did you know that if you press Control Shift Space, it gets smarter? It actually will do chain calls. And sometimes you have to press it twice. So let me show what happens when I have a context local variable. This is a static method that has, well, this doesn't extend any Android classes. But if I press Control Shift once and then twice, notice how it figured out that I had a context variable that it could get a drawable from. So that's really useful. OK. Selection. I've seen a lot of users do this, right? You get the mouse, you're trying to select this part, and you're maybe off by one. Or maybe you do it by the keyboard, and you're pressing and the Shift key while you're selecting. There's a better way of selecting, and that is AST selection. So the action for that is extend selection, I think. Yeah, so you can see the shortcut right there. So you can really quickly select portions based on syntactic elements in the source code, right? And I can press up and down to select outer and inner things. So if I quickly wanted to select, for example, this statement up here, I just tap on it like that, and then 1 or 2, 3 clicks, I have the expression. And I can then press a shortcut to, for example, extract a variable from it. Intentions. Hopefully, you all know what intention actions are now. If not, that is going to be the most useful thing you learn today. Intention actions are these things that are invisible. So they look at where's the caret and what can I do at the caret position. So you can use that to, for example, let's see what we can do on a character. Well, I can convert to a string literal, for example. I really like that when I have a constructor like this and I'm adding more fields. I can invoke an intention action here, and I can bind the constructor to parameter fields. So it very quickly will add variables and initialize it in the constructor. And likewise, if I add a fourth parameter, I can invoke it again, and it'll also insert a field and bind it and so forth. So that's pretty handy. This is also great with instance of check. So I'm sure that many of you have done this, right? You're in here. You made sure your parameter is a context. You don't want to have to go and actually declare a variable. You can just put the caret one line back up, invoke, scroll down. Oh, sorry. That's interesting. I'm seeing different things than you are. OK. So you can put the caret back on the context line. And there is now an intention to insert a variable that's already been cast. It's pretty handy. Suppress. I just want to make sure everyone knows that when you have a warning like this, there's a quick fix, but you can also always press the arrow right to suppress the warning, right? So, and it'll actually highlight the context that the suppress applies to. It's pretty good to know. Live templates. So you never want to go and write a for loop by hand. You can, but there's a better way, and that's using live templates. So if I just type for I, and I press the tab key, it inserts a for skeleton like that. And then you can just tap through. And there's actually, and of course, you'd have the target size. And there's nothing special about I, right? So if I do this, I can also call my variable j, right? And the end condition could be, for example, list size. Now, Romain Guy wanted to show you that you can also use postfix completion for this, right? So you just type the variable you want to iterate over. And then the postfix expression will be for I like this. And that does the same thing. And it's already preset the size. Yeah. All right. Some more stuff on live templates. If you're doing Android development, you're probably doing a lot of logging. And so there's some live templates for that. So I can, for example, type log I to insert a logging statement for info. You can see now that it wants a tag. And so I could, of course, use the normal intention for inserting a tag. And that's going to create a constant that I can add, right? But there actually is another live template for creating a tag, log t. And notice how that actually pre-populates the value with the current class, which is pretty handy. And so there are some additional logging templates. So for example, at the beginning of the method, if I want to log that this method's being called, I just do log m. Notice how that inserts not just the method name, but all the parameters as well. And at the end, maybe I want to log that I'm about to leave the method, so I just do log return. And that inserts, hey, I'm about to return, and here's the result value. So this makes it really easy to add logging. Yay. You're allowed to clap. Filter search. This is actually not code, but navigation. I want to make sure everyone knows that we have invisible searching in almost every list in the IDE. Right? So if I, for example, do Command N, I get this generate list. If I wanted to go for toString, I could use the arrow key, right? But I could, even though there's no search box here, if I start typing toString, you can see it starts filtering. It puts a little text fill on top of it. And this is true basically everywhere. So if I'm over here and I want to do new, if I'm looking for vector, I just type vector, right? And it's navigating right to that wizard. If I'm in the refactoring menu, refactor this, I can search, for example, for the inline refactoring. I can filter the project view, build.gradle. So this, basically, wherever you are and you're trying to search for a long list, just start typing and see what happens. Structural replace. So let me show you this string file I came across in one of our projects. So the translators had translated this, but they left all these translation description elements in. And when you do it like this, it actually gets packaged into the APK, right? So you don't want to do this. So how do I get rid of all these attributes from the translations? You could probably imagine a way to do it with regular expressions, but I'm going to show you a different way that's pretty handy. And that is structural search and replace. So replace structurally, right? So what we're going to do is we're going to search in XML files. And I want to find a string element. If I can type string. And I want a name, and I don't care what the name is. So I'm just going to make a little variable. That'll be a placeholder. I'm going to look for translation description. And the description is going to be whatever it is, another placeholder. And then we're going to have some text. And if the IDE finds this, I want it to basically remove that attribute. So if I've done this correctly, if I search now, it's going to search my project. And it's going to find a bunch of attributes. Nope. Apparently, I didn't do it right. OK, what's the problem here? Oh, you're right. The audience got it. And then we have to fix the value as well. Let's try again. We're searching, and we're seeing matches. So if I open this here, it actually offers to preview the replacement. So if I do that, you can see it's going to do the right thing. So that removes the attribute. And now comes my favorite part. I'm going to open up the inspections UI, and I'm going to navigate to the structural search inspection. I can turn this on, and I can say that I actually want to add a replace template here. And it's going to just show the last one we just did. And when I add this as an inspection, I can also add a message for it. So I'm going to say, please don't include, sorry about the missing apostrophe, please don't include translation descriptions. And notice what happens when we go back to our source file. It's telling us, hey, this is not right. And if I invoke quick fix, oh, it's got it right there. And I can basically apply this. So we can turn a structural search into a quick fix. So if I go back, maybe you have thread.sleep in your source code and you're not super comfortable with having that. Someone filed a bug that lint should flag this, and we should flag that. But in the meantime, if you have APIs that you want to blacklist in your code base at your company, you can do it with structural search. So again, I'll just do a search instead of a replace now. Search structurally. And we can search for thread.sleep. In fact, I'll just say that any duration is a problem. And you can see when I search, it's finding this element syntactically. And I can turn that into a quick warning again. Or the example that Ramagi came up with before this was you can use this to actually replace deprecated APIs with new APIs. So this method is deprecated, and you really should be calling set, well, what is it saying? You should be calling set background, set drawable again, I think. You could do another search and replace on this API. All right. Let's talk about design time attributes. So I'm going to switch to the Topeka app. So this is the puzzle app that we showed earlier. And this is the picture on the left is what it should look like when we run. You can see at the design time, it's not looking quite as nice. And this layout is composed of a couple of elements. So we have an included layout for this avatar. So let's jump to that layout, sign in avatars. And you can see when I'm looking at this layout, I'm only seeing the avatar list. I'm not seeing the list the way it appears in the final layout. So for that, you can use a design time attribute. And one of the new things we have in our current build is code completion actually for design time attributes. So if I do tools, you can see we now have these things showing up. Yay. And so I can now, for example, say I want to show this in, and what is the name of the layout it's coming from? Fragment sign in. Fragment sign in. If I do that, you can see we now see this layout surrounded by the place that will include it. And this, of course, has sort of been translucent gray a little bit so that you don't get confused about what's in this layout and what's in the other layout. Comparing to the image again, still a little ugly. We need to have more columns over here. And so another trick for design time attributes is that I could, of course, just set the number of columns to something like 4, right? But I don't want to do that because this column count is actually computed by Java code at runtime. It looks at the width of the screen and the size of the images and computes it. But at design time, I'm not running that code, right? So let's just say we can put a hard-coded value in the tool, but not at runtime. And the way we do that is just to replace this with a tools namespace. So now you can see it still is showing 4 columns over here, but at runtime, it would not. It's going to be continuing to call the runtime code. So you can call any of these Android attributes. You can just switch to the tools namespace. When we build the app, we strip out these attributes. So they're only used at tool time. Still looking not great. So the other thing we can do is we can look at this. This is a grid view, right? Let's see how the grid view is being used. So I define usages, and we see that it's being used in the sign-in fragment, and it's associated with this avatar adapter, and the avatar adapter is using this item avatar layout. So let's go look at that layout. Well, that looks not great. So this is an avatar view, which of course is being populated dynamically with the right image, right? So one thing we can do, we can just basically update the custom view code to call is in edit mode, which is going to be true in the tool, but not when the app is running. But we can also do this with design time attributes. And the way we would do that is we can say that we want to set the source attribute to, well, let's see. Can I remember? It's a drawable, probably avatar 1. OK, so now we have our avatar 1. OK, and if we now switch back to our list, it's not great because this whole find usages thing I did, I was discovering what layout will actually be used. That was all done through code. The adapter decides what to use. But again, we can use tools attributes, invoke code completion here, tools attributes to say what list item layout to use at design time. So here we can say that we want to use, what was it, item avatar. And now you can see we actually are starting to see a layout that looks pretty close to what's happening at runtime. I realize now that I've actually did something really bad here. I hard-coded the icon to this, and I don't want to do that. I want to switch it to the tools namespace. So if I do that, you can see we have an intention now. So if you just write tools anywhere, you can invoke quick fix, and we add it for you. You don't have to go and copy paste it from some other file. All right, so that was design time attributes. Actually, let me find back where I was. OK. All right, let's talk about private resources. So in my content main layout here, I am using a library. And you can see that my library, my code completion is getting filled up with resources from this third-party library, CCL, whatever that is. And that was not intentional. Those strings are used in the library, but they're not meant for others to use them. So I can actually go into the library source code. Where are you? OK, library, strings. Here you can see one of my string files in the library. And I can say that I basically want to set which resources are exported from this library and which one, and everything else will be treated as private. By the way, one thing I want to show you first is you can see it's highlighting here that this is an unexpected resource name. That's because we have this feature for a library where you can, in the build.gradle, say that you want your resources to all have a certain prefix. And if you declare a resource that doesn't have that prefix, we will warn you about that. So you can sort of be consistent in how you're declaring your resources. Right. So now we're going to go and say that the only resource we expose from this app is this one. So to do that, we can create a XML file. It doesn't matter what you call it. Then I think the best name for it probably would be public.xml. Sadly, we don't let you create one of those because it's a keyword, but that's a bug because it's OK for values. So I'm just going to cheat and use new file instead. And I'm going to put it here. And I'm going to call it public.xml. Resources. And the keyword public is what you use. This is another resource type. You can also write item and then type equals public, but public like this. And I already forgot the name of the resource we want to expose. Well, let's do the first one. And then you have to declare the type. And it's type equals string. So now we've declared this, and I actually have to compile my app because the public declaration is written into this part of the AAR file that the clients will read. So we are building. And if I go back now to my app module, which is digesting the library, what should happen, hopefully, is that when I invoke code completion, yes, you can see it's filtered out all the CCL stuff. So we only get the one thing we basically exposed. And in fact, if I were to try to use some other resource, or if I had been bad in the past and used one of these things that weren't intended to be used, if I use it, you can see we actually warn you that you're using a resource that you're not supposed to use. So if you have a library, you definitely want to look at all the things you're using, your drawables, your styles, and make sure that you really are only exposing for clients the things that they want to see in their code completion list. All right, the last thing I will show you is resource shrinking. So resource shrinking is basically a way to let you strip out all the assets from libraries that you don't actually need. So if you depend on a large library, let's say all the play services, which might include graphics for like the login button, and you're not actually calling those methods, you can get rid of those. You can't go into the source code and delete it, but we can look at the code you're actually calling, and then we can strip out the stuff that's not relevant. So the way that works is that in my build.gradle, I say shrink resources is true. By the way, this only works for when you actually are shrinking, right? We could make it work without it, but it's not really much of a point in that case. So this is when you are, at the end, you're having ProGuard go and figure out exactly the call graph you're using and deleting everything else. And that's what frees up these resources, right? If you're using the login library, Play Services is referencing those icons, right? For the sign-in function. But if you're not calling that function and we strip out that code, well, then the resources become eligible for deletion as well. So you can do shrink resources is true. And when you've done that, our code will be very careful to try not to delete your code, right? So for example, if we see that you have code like this, image underscore %d, so you're formatting something and then you're passing it to this resource manager .get identifier, we don't dare to delete any resource that starts with the prefix img, right? Because this is basically an escape clause to get access to any resource by name. So that's what we do by default to try to not make the app crash. But there actually is a way with design time attributes to tell us that you don't want us to be that careful. So the way you do that is you go into some value file. I'm just going to use strings.xml because why not? And here I can say tools. I'll add the tools namespace. Tools. All right. OK, we haven't actually added strict mode to the completion. That's too bad. So safe is what you usually get out of the box. If you switch this to strict, then we will not consider reflection as a possibility. If you do this, then you are in charge, just like with ProGuard, of providing the keep rules, right? So tools keep is how you specify a comma-separated list of resources that you know might be called from code. And you can also do tools discard if you want to, basically something that you know you want to discard even though somehow we didn't figure out that it was eligible for deletion. And I think with that, I am going to turn it over to the next speaker. Shiva is going to show you how to use the debugger.
Thank you, Tor. Welcome, everyone. I'm going to show, I'll spend the next 5 minutes giving you guys a few tricks about how to use the debugger. So let me start with a very common operation that I do, which is I receive a stack trace. For a long time, I used to look at the stack trace, find the last file, and then go back to the IDE to locate the class. A trick that I learned recently is you just have to search for analyze stack trace. So I press Command-Shift-A, which is find an action by name. That's a very useful shortcut. You do that, and you just start typing for whatever action you're looking for. I type analyze stack trace. Before that, let me just select all of this, and then I do that. It automatically fills this dialog with whatever you have on the clipboard, and you just press OK, and that will automatically populate a console with a clickable list of the files. Now, what is actually even cooler about this Analyze Stack Trace dialog is there are actually two options here. At the top is an option to unscramble your stack trace. So in case you're using ProGuard and you have a scrambled stack trace, then you would use the ProGuard unscramble plugin, and that would be able to normalize the stack trace. And at the very end, you have an option to show the VCS history. So in case you have Git already plugged into your Git or any other version control system plugged into your project, and you do this, it will actually mark the files that have changed in the last n number of days. And you can actually also conveniently look at who committed it, and not to pick on Ben here. But so that is Analyze Stack Trace. Hope you find it useful. Now let's switch to the debugger. I already have the debugger connected to a running app, and I'm waiting on a breakpoint. I'll show you a bunch of things that you can explore in the variables view. So the variables view, which is down here at the bottom, you see all the local variables and fields. By default, we have by default, you would know about the renderings for all the objects, which just use their toString method and just displays that object using its object.toString. And for primitive types, you just render it as a primitive. We have a few other additions, which is, for instance, in case you have a bitmap, you can click on this to view the bitmap. That works for bitmaps and bitmap drawables. And then let's say I'm in a different place, and now I'm looking at different things such as primitives. Now, Android is, we use primitives to express a lot of types. So we use integers as enums, as colors, as references to resources, as resource IDs. And many times when you have an ID and you don't know exactly what it means, you could just see view as and select the type integer. And so an Android typed integer would be able to resolve it to its reference. In this particular case, it happens to be a reference to a drawable. Now, how does this work? This works because of annotations that you might have. We already have annotations in the platform source code, but you could also have annotations in your own source code. So in this particular case, this variable was actually annotated as a drawable resource. And so the annotation could be on the local variable, it could be on a field, it could even be on the getter. We would do sufficient flow analysis to figure out what is the corresponding annotation, and then render an integer in an appropriate manner. This works not just for a reference to a resource, but in this particular case, let's say I have, this is a variable that's called a color, but again, a typed integer, and it references to a theme background. Same with just regular colors. You would see it as, it renders it properly as a color. So that is viewing primitive types. So so far we've looked at just the bitmap, and then we've looked at how to render certain primitives. The other option is you might want to do your own custom rendering. So for instance, instead of the toString method, you might want to render your object in a slightly different way. In this particular class, I'm actually, this is the onBind view holder, part of the Recycler View API. And the model object for this list is actually something called, it holds a list of categories. And if you look at the list of categories by default, this is what is shown there. It basically shows the toString of each category. And many times it may not be exactly what you want to show. So an easy thing to do is just right-click on it and then customize the data view for it. And you would go to Java type renderers, and you would add a new one. Let's call it category. And the object that you want to customize is a category. So it's over here. And then instead of using the default renderer, you want to do something like, I just want to show the name, or I want to show the name plus this is a quiz app, so it has a bunch of questions. So you say that I want to see the name and the number of questions, which would be get quizzes dot size. So I do this, and then now you'll see that each category gets, hold on. As soon as we get this running, maybe I made a mistake over there. Well, it looks like a demo issue right now. But in theory, if it's a category, it'll show you whatever custom rendering you've done over there. Sorry about that. Not actually sure what happened over there. All right, let's move on to the next one, which is how do you evaluate expressions when you're over here. So one common thing we see is that anytime when you want to explore what is happening inside a program and you're waiting on a breakpoint, you can actually select a bunch of text. Let's say in this particular case, I have this, and evaluate and invoke the evaluate expression option. And over here, you can actually invoke whatever you want. So in this particular case, I have a variable category. I can do all the operations. I can inspect. I can basically query methods on that object. And it's not isolated to just that object. You can query for whatever is in the scope. So this is extremely useful when you have like a bunch of Boolean expressions combined together, and you want to see which one is actually false or true. You can actually explore entire APIs this way. So if you have like a bunch of JSON values and you want to see how it's structured, you would just open it up in this and then just gradually query different methods to see exactly what you want. That is evaluate expressions. So far we've looked at what you can do when you're actually waiting on a breakpoint. The other thing I want to show is actually setting these breakpoints in a very conditional manner. So in this particular case, let's say, again, I'm on a recycler view. It has a whole bunch of elements. I press continue. It'll again come back and wait over here. Instead of, so let's just do this. So instead of having to do continue again and again, you might want to make this conditional. So in this particular case, you could make it conditional on category.getName.equals something. So that way, you only stop at a particular breakpoint if you know the exact condition when you actually have to stop. But in case you don't know the exact condition when you want to stop, your normal recourse would be maybe you add a log statement there, you rebuild, reupload. Instead of doing that, you can actually modify the breakpoint itself to log a particular expression whenever it hits the breakpoint. To do that, you would go into the more options here, and then you would deselect the suspend so that when it hits the breakpoint, you don't actually want to suspend, but instead you want to log a particular expression that you evaluate. So let's say I just want to see what the category name is whenever it comes over here, and I press continue, and now you will see that. Let me remove this breakpoint. Over here, you've started seeing the category names being, so you can see as I go through it, whenever it hits the breakpoint, it'll basically log exactly the expression that you had provided over there. That is actually all I had. I hope you found it useful. Thank you.
Thank you, Shiva. My name is Alex. I'm going to talk about Gradle integration. One of the common questions that we get from the Android developers using Eclipse is, I have this compile AR, this library that I'm using in my Eclipse projects, but I also want to use it from my new app in Android Studio. What do we do? So we can either copy the file. There's a lot of things that we can do. Create a local Maven repository and install the AR there. But Android Studio actually provides a very nice shortcut. And you can actually import the compile AR as a regular module. And I'm going to show you how. So we create first a new module. There, then we select import AR package. After you click import, this wizard is going to ask you for the path in the file system of the AR that you want to import. To save some time, I already did this, and I'm going to show you how it looks like. So here, there it is. That's the module that was created by Android Studio. It creates the module, the build.gradle file, and also the AR that is wrapping. After that, I added a dependency in my app, just like I would depend on any other module here. And I'm ready to use this code. For this example, I imported a tip calculator. So now, in my activity, I can just start using the code. Very simple. The second tip for the Gradle integration in Android Studio is, how do I run any Gradle task without leaving my IDE? So this is something very handy that we inherit from IntelliJ IDEA, which is the Gradle task view. So here you're going to see all the Gradle tasks that are available for your project. They're categorized by the top level module, which is the project, the module. And here, for example, I'm going to select dependencies. So if you're familiar with dependencies task, it's going to show you a very nice tree view of all the dependencies of your module. So I'm going to just double-click this. It's going to execute. Executing. And, well, sadly, didn't like how the way it was executed. Because to execute dependencies, you have to prepend the Gradle path of the module that you are using. But we can fix that very easily. The cool thing about this is that the IDE, Android Studio, will create a run configuration for that task that you just executed. So we go here. We edit the configuration. It's this one. We fix it. Oops. There. We apply the changes. Click OK. Run again. And there you go. The problem is that the text is a little small, so you cannot see it. But it's there. And it looks very cool. So besides creating the run configuration and allow you to edit it, you can save it. So you can preserve that run configuration between IDE sessions, which is pretty handy. And the last thing I'd like to talk about is build variants. So by now, I am assuming that everybody here is familiar with build variants, right? Please raise your hand. Yeah? Yeah. For the folks who didn't raise your hand, please, I recommend you to please watch the Gradle talk when it's available online. So build variants are different flavors of your application inside your code base. And we usually get asked, where do I see these things? And they're kind of hidden in the IDE. So they are here. So actually, let me minimize this and this. So here. So this is the build variants window. It's on the left, bottom left. And here you have the list of modules in your project. These are only Android modules because they're the ones with build variants. And here, each module, each row for the module has a drop-down where you can select the variant you want to work on. You can work only with one variant at a time. Something that's a little sad is that each build variant has 2 test artifacts. And because of limitations in the IDE before, you can only work with 1 test artifact at a time. So you can either work with Android tests or unit tests, but not both. So if you want to run tests continuously, you have to keep switching between them, which is not very, very convenient. And another thing is that by having only 1 test artifact enabled at the same time, one enabled at a time, refactoring doesn't work. And I'll show you what do I mean. So let's say that I have Android tests enable. And I have this method here. I rename it. There. So my Android test participated in the automatic refactoring and was updated properly. But the problem is that the unit test wasn't, because it's not enabled. So when I switch to unit tests, it's broken. And then you have to manually fix that. So that's not really awesome. So let's undo that. Did that? Yeah. Let's remove this. OK, so how can we make things better? So starting with Android Studio 2.0, you can have both test artifacts enabled at the same time. It is an experimental feature. It's not on by default. But it will be super great if you can try it out and give us some feedback. How to enable this? You go to the Preferences. And there is a tab. So you go to Build, Execution, Deployment, Gradle, Build Tools, Gradle, Experimental. And there is this option, Enable all test artifacts. You enable that, click OK. The dropdown is gone. The unit test is active. Also, I wanted to show you something else. If you see the Android test, the folder has a little Android head there. So at least you can somehow distinguish which one is the unit test and the Android test. And now if I refactor this again like I did before, now let's see, Android test. Beautiful. It was updated. And also, the unit test was updated. Yeah. And that's it for me. Here's Michael, who's going to talk more about testing in Android Studio.
Hello, hi. Yeah, can we switch to the other computer, please? OK, perfect. Let me show you a couple of useful tricks that come in handy when writing test code. So the first thing I'd like to show is the create test intention, which is available when my cursor is on a class definition. So here I'm going to press Alt-Enter and choose create test. In the dialog I'm getting, I can choose the name of my new test. Demo activity test sounds fine. So let's move forward. And with our new support for having both test sources active, now I should choose which one I want to use. So let's use Android test for now. And now I got my new test class, which is created in the right place in my project structure. You can see all the intermediate directories got created. So that's quite convenient. Let's fill it in with some content. There was a session dedicated to testing earlier today. So if you haven't seen it, I recommend you watch the video. Because for the purposes of this demo, I'm just going to do something very, very simple. Let's just add an activity test rule for my demo activity. And it can even suggest me a good name for my field. And now I want new activity test rule, demo activity. Perfect. Next thing I'd like to show is the generate command that Tor already mentioned. That's Command N on the Mac. And in the test context, I can use it to generate a test method. So in this case, let's call it test basics. Okay, and let me just do something very simple here. I'll use activity test rule, get activity, and I can play with postfix completion, for example, the .var to actually assign it to a variable. I leave it at that for now, but let me show you something else. On any kind of field declaration, including rules for testing, I can again use intentions to move initializer to setup method, which is quite convenient if you find yourself in a position where your test setup is becoming more complicated. So when I press enter, Studio will generate a new setup method for me, annotated with @before, and move the initialization here. I can also use intentions to get rid of the unnecessary generic parameter. OK, next thing I'd like to show is go to test. So on a Mac, that's Shift Command T. So when I press it, I can jump between my main code and my test code. So from the demo activity, I can go to the test. From the test, I can go back to activity. You may also notice that the pop-up for go to test allows me to create a new test as well. So let's do that now. Because for a change, I would like to create a unit test that will execute locally on my machine. And there's one method I'm particularly interested in, the generate secret key method. Let's press OK. This time, let's make sure it ends up in the test source set. OK. Again, we end up with a test created in the right directory with the test pre-generated for me. Let me put something very simple here. Assert true. Yeah. Let's just make sure our keys are positive integers. So Studio 2.0 is based on IntelliJ 15, which means that on the left margin here, we have icons that I can use for running tests. So when I click it, I can choose to run my test. And let's see it run. Perfect, all green. That's exactly how I like it. OK, so last but not least, if I decide to go back to my activity and now decide that with all the added test coverage, it's actually ready for production, I can rename my demo activity to main activity. And Studio will notice that I have tests that correspond to my demo activity, and they should probably be renamed as well. So my demo activity test becomes main activity test, and demo activity unit test becomes main activity unit test. So that's a very good idea. Let's do that. I'll click select all, and OK. OK, now that we're done, let me just close it. I can go to test. I can see my tests have been renamed. And both of them use the new activity name exactly as I would expect. OK, thank you. And now, Catherine will tell you all about our C++ support.
All right, let's see. All right, so I'm going to just cover a, I guess, smattering of C++ topics. We already saw some of the things like intentions. They're totally supported for C++. If you're curious, you can find them in the settings and check out previous videos. This is more topics that have been previously covered. So things that are new in Studio for C++ and that you might not know about. One of the things is that we have recently added Doxygen support. So when you've been using C++ historically, you may have noticed that, for example, if you hit F1 to bring up the docs, you can see details on like where macro is defined, what the expansion is. Similar to that, we now have this syntax. It's kind of akin to Java docs. You can add it for a function. And then when you go actually look at the definition, this one's very dull, but you can imagine putting in as much detail as you may find useful. So it may be helpful documenting large projects. Other new support. Let's see if we've got this running yet. So this is a hybrid activity. And I've added a breakpoint here in the Java code right before we go into this native call, get string from native. Once I've done that, this microphone, I've gone and edited my debug configuration to make sure that the debugger type is hybrid, because I'm curious about both my Java and my C++ execution. And then I've actually launched a debugger, hopefully. Or I am launching a debugger. For those of you who don't have the superpower of reading like size 2 font, it looks like we're about to run. This is totally the curse of the live demo. Super suspicious. All right, well, at least in theory, we now have the ability to step from Java code into C++ code. We will give this another 30 seconds before we declare it to be primarily theoretical. Oh, come on. Well, that thinks about itself. So this was supposed to be the stable functionality. And then we have some experimental functionality that should also be helpful for folks doing hybrid apps. So we'll come back to that. Sorry, something totally messed with my emulator configuration right before this started. So historically, you're running a hybrid app. And this is an example. I've got an app which has a bunch of Java code. And I've got a library with a bunch of C++ code. I want to express a reasonable dependency that doesn't involve like hard coding linker flags. So we've added a experimental first class syntax for doing this. In this case, I'm going to say I have a JNI lib dependency on project lib. By default, it's going to pull in the same build type and flavor that my actual build is using. You can override this if you like. And this thing is not taking well to the huge font, but by default, you're going to get dynamic linking. If you want static linking, specify it. You can also define dependencies on pre-built SOs, so library file. And if you define that as a JNI lib dependency, you're basically saying to package it only. If you define it as a JNI dependency, then it's a build time dependency. And this is experimental, not because we think it may sometimes fail to work, but just because we know we're going to be changing the DSL at some point in the future. So if you think this is useful, go ahead and use it and try it. Just be warned that in the next N months, you're likely going to have to go tweak your Gradle syntax. The other feature we have that is more genuinely experimental is for C++, I forgot to put it in here. We've actually added the specification for, I can now say CPP flags, if I can type, for split dwarf builds. Oh, here's my debugger. So I guess finishing one thought at a time. Split dwarf builds, if you're not familiar with it, when you start running a debug build in C++, the compiler is going to shove all of the debug information into your objects. And this may result in substantially larger files that then take your linker a much longer time to process. If you use the split dwarf flag, you're going to keep the debug information out of the objects that the linker processes. And it may result in like a 10% or more increase in link time, particularly when you are seeing slow link times because of big files with tons of debug information. That one is more genuinely experimental. It's a new compiler flag out in the wild for the first time. So give it a shot, and if it frankly fails to compile, please tell us, we'll fix it. So going back then to our debugger, I placed the breakpoint here in the Java code. You can see I've got my Java debugger open. I can start examining all of the objects in here. But then what happens when I start stepping forward? So now I'm stepping into the C++ code. And it should momentarily hand this off to the C++ debugger and let me see all that memory state, assuming the curse of the live demo does not continue. Up native. Oh, come on. Oh, here we go. So we've totally got native code here. I can keep on stepping forward. I can go just to my next breakpoint. And the other thing you may notice is that we've added significantly better display if you're using the STL. So I can actually start inspecting my templates, seeing what's in here. And then if I'm running on x86 or a Nexus 9 emulator like I conveniently picked, I can start adding things to watches and continue working with the C++ code. So yeah, as I step through, everything updates. So again, play with the C++ debugger, let us know how it's working, and we're going to be continuing to update this. So if you have things you really want to see, the squeaky wheel typically gets the grease here. All right, so Gradle support, debugger, editing. The next thing is going to be a total change in projects. You may have noticed during the keynote yesterday, we announced a snazzy new, and this is maybe beyond experimental, this is maybe super ultra preview alpha. But we announced a GPU profiler. So come back to Studio. So here is a project with a bunch of GL code. And there's 2 steps to getting the GPU profiler working, which I've sneakily done ahead of time. You have to add a trace library to your project. It's distributed with the profiler, so you just copy it in place. And then you have to add a little bit of, a couple calls in order to actually load it. Once you've loaded it, you'll see that there is a new button available over here. Oh, come on. Where is my monitor? Well, if I could expand the monitor tab, there's a little red button for running a trace. When you launch an application with the profiling library included in it, the application is actually going to block on startup because it needs to start sending all of the GPU data back to Studio so that we can collect the trace. So the first time you run your application, you're going to see this exciting black screen while it waits for you to hit the trace button on the GPU tab. Don't freak out, just go hit the trace button. And be sure to remove it before you send this thing to prod. Once you've run the trace, you should get something like this. So I can see all of the frames that were captured while I interacted with my app. For any given frame, you can see depth buffer. You can start seeing wireframe view. And then I can actually expand the draw calls that went into it. So let's look at one of these guys. So here's all the OpenGL calls. In cases where I was dealing with memory, I can click on this. Oh, and normally the text isn't clipped like this. We blew up the size to make it look good on the monitor, and now everything is slightly confused. But when I'm inspecting the memory, I can actually see what matrix I was using. Again, this works better when my text size is not gargantuan relative to my screen dimensions. And I can explore the GPU state that was around for this. So down here, I've got, let's say, my shaders. I can see all of the information that was actually being used to generate the scene. And then as I click through the different draw calls, you can also see the different elements being drawn. So it's going to look better if I don't have it on the wireframe mode. Like, for example, if I stepped through the draw calls on this, I'd see the foreground coming in, then the background, etc. Again, this is highly preview functionality, but if you think it looks interesting, give it a shot. Let us know what works and what doesn't. There's a couple gotchas around what we know are currently unsupported features. For this, you can see them on the help docs, and we'll be hopefully relaxing them over time. So with that, here's Esteban for non-GPU profiling.
Hello, everyone. So I'm going to be talking the next 15 minutes about our performance tools in Android Studio. I'm still booting my emulator, so bear with me 1 second. In the last few days, I put together a quick app that I want to show you guys. It's basically an app that has quite a few bugs hidden in there, and I want us together to use the monitors in Android Studio to see those, to see if we can detect something there and find those bugs and fix them. So let me run the app. The app is now installing in the emulator. So for those of you not familiar with the emulators, with the monitors, they are in the Under Monitor tab at the bottom of the screen. I will hide it for a second while I run you through my amazing app. This is a slideshow app, so I'm getting some images from the web. I'm downloading them, and you have a next button there to go to the next image. You can go back. The simple app, and I'm showing the time at the top just because I want to know what time it is. And I also have a menu with a few options to have there. The first option is a clear cache. So I have a small cache of 5 images at the same time in memory, so I don't download them when you go back and forth. So you can go and clear the cache. And I also have 2 filters. I have a sepia filter, which is quite popular, and there you go. You have the sepia image. And I also have another filter that is a sharpen filter. For those of you that are not familiar with filters, sepia filter is very simple because you only modify each pixel at a time, whereas a sharpen filter needs to look at, there's a kernel matrix and needs to look at the surrounding pixels, so it takes more time. The reason I have that filter is because we're going to be looking at some CPU activity and see whether this filter actually shows up in the CPU monitor as something being expensive. And there you go, the image is now sharpened. So that's my app. Now let's look at the same thing, but now hooking it up to the monitors in Android Studio. I'm going to uninstall the app right now. If you watched the keynote yesterday, you saw that we had a tiny bug with instant run. So I don't want to run into that bug right now. So I just uninstalled the app, and I'm going to run it again. We just did five live demos in a row. Mine is the 6th one. What can go wrong, right? Cool. I'm going to run it again here. And then we'll see the app connected to the monitors. Just for curiosity, how many of you have tried the CPU monitor, memory monitor? Can you raise your hand? Oh, cool. All right. Right, here's my app. Network monitors. I'm going to expand this. Can you at the back see the memory, the CPU monitor, the one at the bottom? Yeah? Yeah. If you don't say no, then that means you're seeing it. Cool. Now this is my app again. And let's see if we can spot some bugs, right? So I'm going to go to the next image. The first monitor at the top is a network monitor. We recently added this monitor. And as you can see, when I'm requesting a new image, you can see a new request. That's above the 0 line. you're seeing the bytes that are coming in, and below is the bytes that are going out. So the request is basically tiny, but you can see the image being downloaded. The area of the thing you're looking at there is telling you how many bytes you're actually downloaded. So on the x-axis, you have time. On the y-axis, you have speed. And the area is the amount of bytes. So you can see the bigger the area, the bigger the request was. And clearly, I have a cache. So when I go back, there shouldn't be any requests happening there. That's a bug, right? That's how you spot a bug. So my cache is not working. I'm going to go to my image loader. There's no space to see the monitors and the code at the same time. Looking at my image loader, I decided to add the image to the cache on the catch part of my code. That was the wrong place. I just moved it up, and I'm going to use instant run. And yeah, hey, instant run is working. So I just use instant run, and I'm going to reopen the monitors and see what happens. So I'm going to go to the next image. This should request the image because we haven't seen it. Cool. One more time. This image is a new image, and now I'm going back. No network request. The bug was fixed. Cool. So now that we have the cache working fantastically well, we're going to move on to the next thing. I'm going to run, we thought Sepia filter is fast. We saw the image updating fast. Sharpen uses a lot of CPU. So I'm going to run my Sepia filter, and clearly we'll see one spike on the CPU monitor, and that's it, right? My CPU monitor is now back to no, it's doing stuff. What did I do? So we go back to where I'm calling that. By the way, if I open the monitor, it's down. Hey, okay, it did do something. So I'm going to look where I'm calling this function, and you can see I have, you guys know the on option item selected callback that you get, and I have my Sepia filter here and my sharpen filter. Okay, I forgot a break. So whenever I was doing a Sepia filter, I was also doing a sharpen filter. We don't want that. So I'm going to put a break here, run this new magic thing that we have, and open up the monitor. Let's go to another image and run Sepia. CPU spike, done. That's what you would expect when you fix this bug. Cool. Now let's move on to another bug. I'm going to run again the sharpen filter. This, as expected, will use a lot of CPU. And now it's done. But I'm gonna switch to a different monitor, the memory monitor. I was not expecting at all this filter to have any memory activity, right? So you see like the seesaw pattern there at the same time that the CPU spiked. So why is this happening? When you see a pattern of this form, generally it means that you're doing a lot of allocations in a short period of time, and you're getting your garbage collection kicking in and bringing them back, right? So I'm going to do the same thing, but this time I'm going to run it through the allocation tracker. The allocation tracker, what it does is you start at a moment in time, it captures all the allocations that are happening, and then you can go and dig into these allocations, right? So let's do it. I'm running sharpen, and I'm going to start allocation tracking. You can see in the memory monitor what is the time frame that I'm doing this tracking. I'm going to stop it here. Let me minimize the monitor so we can see. Here we go. So now the file is being transferred over to Android Studio. And then we see thread 1, 36 allocations, thread 3, 10 allocations. Thread 13 decided to do 65,000 allocations. Something is wrong. How do we go there? OK. I'm going to start opening this guy. You can see the asynchronous task that I used to do the filter. You can keep digging, and it goes into the filter image. Sorry, we have super huge fonts, so you guys can see. But I keep digging 65,000 allocations. I get to the sharpen call. I open it up. Gazillion long allocations. Why is this happening? I'm going to go to source. There's an action there to jump to source. Looking at my code. A standard filter code, you have 2 nested for loops that go through all the pixels. OK, I have a new allocation of an array inside this. So these images are 1,000 by 1,000 roughly. I'm doing quite a lot of allocations. I'm going to move this out of the loops, which is, it doesn't need to be the allocation in the loop. I'm going to press the magic button again. And let's open the monitors. Cool. Now, let's try again in another image. Oh, that image, after 2 sharpen filters, looked beautiful. OK. Sharpen. CPU activity, as you could expect, the memory, safe and sound. That's how you spot and how you track down allocation bugs. There is another thing I want to show you on the allocation view. Here we go. So this image utils class, the one that was doing the draw of allocations, I have it in a package called third-party images package, right? Imagine you are using a library that you didn't write, but you're calling it from several places of your code, and that library seems to be doing a lot of allocations. If you use this view on the allocation tracker, you're going to find that all these allocations are being blamed on those packages. You're going to drill down and say, oh, it's again this library, it's again this library, right? When you do an allocation, what you see is the call stack, right? So you see all the call stack, and then the final function in the call stack is going to be the one that you blame to say, OK, that's the one that did the allocation. However, maybe one of your classes is responsible before that call happened, right? So you don't want to go directly to the class that called new, but you want to go back and say, OK, which one of my classes is actually the one calling this? So for that, there is a different view that you can use, which we call group by allocator. When you do this, instead of using the call stack as the guide to group the allocations, we use the package names. So here, like I was saying before, you can see that com third-party images was the package that was doing all the allocations. Not helpful at all. We have a box here where you can specify the package that you want to highlight. So if there's an allocation that goes through many things, but you want the last thing to be one of your package, I can put com.example, which was my applications package. And now you can see that whenever we see an allocation, we will not blame it on the very deep call, but we will blame it on my last call. So now you can go and see that com example dev summit main activity is the class to blame for all these allocations. So with this, you can better track the culprits of several allocations. Cool. So going back to the app, the last thing that I want to show you guys is my app is here. I'm going to restart the activity. I could rotate the emulator and it will go off screen. So I'm going to we have a new shortcut to restart the activity. Everyone knows that when an activity restarts, we need to be very careful about a few things, right? We need to be careful about the onCreate method being called again. So if we create some things there that we don't dispose, there will be a leak, right? And leaking activities is one of the most common things that happen when this is not handled correctly. So I'm gonna, while we keep looking at this, I'm gonna restart the activity a few times. It is obviously expected to see some memory activity here, right? Because the old activity is gone, some things go, and the garbage collector kicks in slightly later. So I'm restarting the activity quite a few times. The purpose of this demo is to show you guys when you see a pattern on the monitors that is incorrect, something that should not happen. A typical pattern of something that should not happen is that pattern, right? I am leaking something. Just as a last resort, I'm going to go and run a garbage collection and hope everything goes away. No, it doesn't. So there is a bug. How do we find this? Well, the thing you do is you do a heap dump and dig through your stuff and look, what are the things that we are leaking. To save time, I already have a heap dump here that I took of a very similar scenario. The fonts are huge, so in your computer you will not see it like this, but we blew up the font so you can read from there. I could now go and dig in and find where are my activities, how many do I have. We added this very handy thing that is called analyzer tasks, that we can automatically run some tasks for you, and we detect common patterns of things. We have this long list of 2 things that we detect now, but we obviously with time we'll be adding more. The most important we have now is detect leaked activities. I open the leaked activities, I leak the activity every time that I was rotating, right? If you look at all the instances of main activity, I have 7 instances of main activity, and 6 of them were leaked. That means that there is something on my app that is keeping a reference to them, and with that, it keeps all the resources of that activity. So how do we find that? Cool, let's click on one of the leaked activities. If you click here, it will click on the main view and will select the instance. And then on the bottom pane, you can see all the references to that, right? So you will see the reverse references to your object. So this tells you which are the objects that keep a reference to me. We sort this by the distance to the nearest root. That means the nearest garbage collection root. That means that if you expand the tree and you go on the first child, you're going to get to the root pretty quickly. And that is, in most cases, the one that is keeping you in memory. On top of that, there is a lot of dominator calculation, retain size that you can look at the documentation and find what these things mean. But I'm going to quickly go and see if I can just spot the culprit of this. I have my main activity, and I have a clock updater that is a thread, and this is the root. So why is this still there? I'm going to go to my code and see why clock updater keeps a reference to my activity. This is a thread. This, don't do this at home kind of thing. I'm going to look at all the usages of this. I actually know them. Here are the ones. It's in the main activity. I start this thread on onCreate, and oops, I left this commented out. This is why my thread was not stopping. I'm going to press the magic button again. Cool. Let's open the monitors. Right. I'm going to start restarting the activity and see if the memory does something. There we go. Like we said, some activity on the memory is expected. This thing is going up. Garbage collection. I'm going to click on the garbage collection button, see if there is a drop. I think we're good. Yep. Memory is stable. Once again, there is a garbage collection, and we are back to where we should be. So the last monitor I want to show you is an experimental monitor that we have, and is the GPU monitor. It's disabled by default because when you enable this, you might see some interference with the other monitors. So whenever we query the device to get some GPU activity, some allocations are happening, and you will see your memory monitor moving up and down. So we have it disabled for now, disabled by default. I'm going to enable it. For those of you familiar with on-device, when you go settings, developer options, something, then you go and enable GPU profiling. You see on-device how long each frame is taking. We're showing the same thing on Studio, so you can see it at the same time as the other monitors. I'm going to start doing something on my app, and you will see some activity. We have two lines there. We have the red line and the green line. The green line is 60 frames per second. Everything below that is super fine. Then the other line is 30 frames per second. You should really go over that. One is at 16.6 milliseconds. The other one is at double that. And you can see here that whenever I'm rendering a new image, depending on the size of the image, we are going over the limit. The reason for this is I'm not scaling the images at all. I'm rendering them as the original size. And this will take some time. I'm not going to fix that using Instant Run. Forgive me for that. It's a bit more involved. But this is how you would use the GPU monitor. So this is the last monitor that I wanted to show you. And I wanted to close with a few words of where we are going with the performance tools in Studio. So our idea is to have the monitors as a very quick thing for you guys to look at your app, see is everything fine or not, and move all the analysis that we could do automatically to the monitor, so you don't have to profile. We'll do that live for you, and we will highlight the issues there. And hopefully in the next releases, the next year, you're going to see improvements on this area, and will help you have healthier applications. Thank you. With that, I'm going to invite my colleagues back on stage, and we'll be happy to answer any questions you may have.
So there's microphones on both sides. All right. No questions? Is there anything else you want to see? All right, we have a question.
Yes. I have a question about these performance tools. Before, a lot of tools can be opened the standalone app, like a monitor or a view tracer. Could these tools can be opened without Android Studio?
I was going to say, right now, we are moving away from that. That's how we used to do things. We used to have sort of separate standalone tools, and we're trying to put everything into the IDE. And do you want to speak more to the performance tool specifically?
Yeah, so exactly what he said, we are bringing all these tools back into Studio. And the reason we're doing that is so, as you can see, you can see multiple monitors at the same time, and we can do more analysis. The idea is to integrate everything into a more cohesive experience, so you don't have to switch between different tools. And we could having them inside Studio gives us the chance of, because we are the IDE, we can see all your code, we can explore the code, and we could do from static analysis to live performance. We can do all the spectrum of analysis. That's why we're bringing it all into Studio.
But the reason I ask is sometimes open Android Studio is quite slow, so I would prefer just open a standalone app, and just because tracing memory issues or performance take a long time, many times. So if just can open with one app and hook up with device or hook up with the simulator and the monitor, can be easier.
So you do only analysis, not coding or debugging, or?
We will like coding and debugging, but after we find the issues, we can go.
Then you want to exit Android Studio and just do your analysis.
Yeah.
Okay. Yeah. The problem is that for us, there's a lot of convenience to actually being integrated. For example, like you saw all the text fields, we do auto-completion on code, for example, and that needs to know about where's your code and what's the project context and the class path. And so integrating them allows us to do a better feature than when we have really standalone tools. So that's why we're doing that deliberately. All right, let's go to that side.
Do you have any update on the NDKit side to analyze memory like Valgrind? Running Valgrind in the device is a pretty painful thing to do. So I don't know if you have any update on that.
So I don't think we have an update right now, but I would say that in general, we recognize strongly the need for expanded performance tools that would cover NDK development, and you should just stay tuned. I'm sorry for the lack of specificity.
I was noticing that for shrink resources, you had that like tools keep annotation in case you just needed to tell the system to keep something.
It's like the ProGuard file, basically, where you write, yeah.
So I was wondering, how do you do that for resources that aren't defined in XML, like something in raw?
Well, those will be @raw/ and then the name of the resource.
Oh, so you define that in like an XML file?
Yeah, so I think whenever you put something in raw, they also get a actual field name in the R class. So the resource type is raw, and then there's the name that field has.
Okay.
Yep.
So Java packages exist so you can organize your Java code and split it up however you want. But there aren't really clear ways of organizing resources. So if you have a large app, you may have dozens, if not hundreds, of layout files or drawable files. Are there any plans or strategies for organizing resources similar to how you might organize other things?
Okay, so I don't think we have any concrete plans. I know that people have posted this workaround on social media where you basically nest the folders and you tell Gradle about this, but there are some serious downsides with that approach. So I think for now, what I've seen apps do is they basically use a prefix, right? So you sort of do, organize everything by a common prefix, underscore, and then the rest of the resource. And I don't think it's easier to do more than that. I guess you can use libraries too, but it might not be very natural. Anyone else want to say anything about that? Michael? Gradle? No? Okay. All right.
Hi. So you showed some really cool stuff that looks like ends up being configuration saved in the local IDE for one programmer. How do you see us sharing that in the team, especially, for example, the structural replace, talking about the translation thing that the translation team shouldn't do, that kind of thing?
I think a lot of these things actually do get saved as project settings. And so I think by default, so when we make a new project, we put a git ignore. We know that not everyone uses git ignore, but if you use Mercurial, you probably can translate it yourself. So the git ignore is basically documenting what we think you want to include and exclude. And I think we actually do encourage you to check the .idea folder into version control, because that's where you store things like code styles. I know in IntelliJ 15, you also can import and export code styles really conveniently. But I think at least the structural replace gets saved there. So, yeah.
Thank you.
Mm-hmm. Do you have any plans for adding strace support or sort of bringing in the web-based traces to IntelliJ?
Yes. Do you want more detail on that? No, yeah. We, like I said, we're planning on bringing all the performance tools into Studio, and that's a very handy one. So it's going to be in the list.
Okay.
Hi, Android Studio 2 looks amazing, but I have a very simple question about find usages. Is there like an easy way to prevent it from listing usages in generated stuff like merged, intermediates,
Yeah, I think that's actually a question for Alex, because in general, we try not to do that, right?
Yeah, but I think that's a bug now.
Okay,
Yeah.
you found
We
a
have to
bug.
fix it.
Yeah, we basically, we do in Gradle Sync, you do a lot of work
Yeah.
to make sure that generated things are recognized as generated.
But we still have to do more work to get those generated code outside some searches and refactoring targets.
Do you already have a bug tracking that?
I think so.
Okay, yeah.
Thank you.
Alex is working on it.
Hi. I really like the debugger, but sometimes in some projects it tries to resolve my variables and it doesn't seem to be able to do that. Is this something you recognize as well, or what's the, kind of the remedy to get it working again?
When you say it does not recognize, are you talking about it gets stuck, or are you just saying?
It just cannot resolve the variables at a breakpoint, so to speak.
Well, resolving a variable, I'm not sure if it's like a scope issue, if it's stuck at a wrong area and that variable is just not visible in that scope, or it's more of an issue of there is an issue with the connection and then it doesn't get through. But if it's like something that is very specific and very reproducible, you should certainly file a bug. As long as it's there in the scope, it should be there. It should be visible.
Okay, but not like clean project or restart Android Studio?
You shouldn't, I mean, of course you shouldn't have to do all that. Certainly file a bug, please.
Do you guys have any plans for improving or integrating hierarchy viewer and like improved view tree editing, reviewing?
That is correct. That is coming through pretty soon, like over the next year, we'll see it. Pretty much all the tools that are present in DDMS, I think all the performance tools will come in Android Studio. Anything that was part of either standalone or present in DDMS Monitor, you will see all of them being integrated into Android Studio.
Yeah, I think the only reason Monitor is a separate tool today is that we haven't replaced absolutely everything yet.
Yes.
Yeah.
Still about the standalone performance tool, my coworker pointed out, like, do you have any plan to make some output so we can use this performance tool in the CI so we can automatically detect the performance issues?
Yes. Yes. So part of the thing we plan to do is we have this in a separate library that you could call command line all these analyses that we'll do. So the idea is that you can write regression tests or whatever you need to make sure that your application doesn't regress on the performance space. So that'll be covered, yes.
Thanks.
Is there something in Espresso as well for doing performance testing?
Yes, it was mentioned in the testing talk. So yeah, I recommend you watch it later.
Yeah. Okay. Any other questions?
Everyone knows everything they would possibly want to know about Studio.
Cool.
Okay, in that case,
Okay.
thank you very much for your time.
Thank you.
Yeah.